Hello, everyone, and thanks for joining us today for a PV Magazine webinar. Today, we will cover algorithms for solar tracker optimization under adverse conditions. Our discussion participants today are Mireya Jimenez, Product Manager from Soltec, Magnus Herz, Project Manager from TÜV Rheinland Solar, and Emilio Marcanel, Chief Operating Officer from PowerTease. My name is Ryan Kennedy. I'm editor at PV Magazine USA, and I'll be our moderator today. Optimizing solar production while ensuring safety and resilience requires powerful, intelligent tracking systems. Powered by algorithms, single-access PV tracking systems can empower bankable, productive, and resilient systems. While protection algorithms are necessary to preserve systems, delicate balance must be struck between optimization and safety to make the most of a solar asset. This webinar will take a tour through the experience of a developer using solar tracker systems empowered by such algorithms. It'll examine the logic behind the trackers, and we'll review the verification of the optimization parameters. In this PV Magazine webinar, Emilio Marcanel, Chief Operating Officer at PowerTease, we'll discuss how the developer tried to maximize generation by analyzing current technology, including trackers, modules, inverters, algorithms, and design elements. Mireya Jimenez, Product Manager at Soltec, will guide us through the logic behind the Soltec Solar Tracker product, and we'll be acquainted with the novel implementation of the Team Track and Diffuse Booster technologies that boost power while minimizing the impacts of high winds, hail, snow, and other adverse weather effects. The webinar will review the challenges onset by the aeroelastic effect of winds and how Soltec trackers tackle these challenges with an intelligent and holistic approach. The presentation will examine how electronics improvements like the inclusion of a fully wireless system are required to manage systems that are faced with weather phenomena like cyclones, high wind, and electrical storms. And finally, Magnus Herz, Project Manager at TÜV Rheinland Solar, will take us through how products and services are certified to de-risk projects and to ensure that technologies are working as intended. Over the course of the webinar, we'll get to know Soltec algorithms to maximize the performance of a PV plant. We'll understand how a certifier measures these parameters, and then we'll take a look at which parameters are taken into account by a developer. Questions can be submitted beforehand or during the webinar in a chat window, and we'll hold a question and answer session at the end of presentations. If you enjoy the PV Magazine moderated content, please consider subscribing to our newsletter and international print magazine, and stay tuned for future webinars. And now I'll turn it over to Emilio Marcanel, Chief Operating Officer, PowerTease.
So thank you very much, Ryan, and thank you to PV Magazine for organizing this webinar. So my name is Emilio Marcanel. I'm the Director of Operations for PowerTease, and also I'm leading the development activities in the US for PowerTease. PowerTease is a part of Soltec Power Holdings, which Mireya will explain further in her speech. But anyway, Soltec is a vertically integrated company. It's a world leader manufacturer in trackers. It has been for many years in the industry. Its headquarters in Spain, in Murcia, where they have the research and development, manufacturing, and the logistic hub for where it serves the whole world. The current track record, it's beyond right now 12.7 gigawatts, and the market presence is all over the Americas, Europe, Africa, Middle East, and Australia. Regarding Powertis, we are a large-scale solar manufacturer, solar developer. Our main markets are in the Americas and Europe. We have a strong portfolio of 11.6 gigawatts under development right now. Our presence is in 8 countries right now: Spain, Brazil, Italy, the US, Denmark, Colombia, Mexico, and Romania. We are already 85 employees, and we are in a good position, very good position. We like this position because we control the entire product value chain through without being part of Soltec. But we can use Soltec trackers and Soltec construction and Soltec O&M. So it's we are in a strong position because we control the value chain of our projects. This is just a rough indication on how we are, distributed throughout the world. And today, what I'm going to talk is about how we maximize generation or optimize, depending how you consider this. But in the end, what we do is we leverage on technology to try to get the best projects outside, for our clients or for ourselves. And what we do is we try to maximize generation, and we will look at this LCOE formula that everybody probably will know. So in the denominator, we have the end present value of generation, and in the numerator, we have the net present value of the cost associated to the project. So we try to maximize the generation while maintaining the cost. Okay, and we do this through technology. So I'm going to talk now about the modules and how for the last years have been evolving. So until now, for the last 3 years, starting in 2019, the mainstream technology was the PPERG, which was, at the time, was the most common for sure, and it is actually still the most common, but has it's limited efficiency and relatively low bifaciality coefficient. But right now, it's the best price. In 2022 show how things changed until now, until very recent. Manufacturers, they just were focusing on getting larger modules in size, but keeping the same efficiency. So not real gain. I mean, some savings maybe in altogether, but some savings in BOP, but not really, nothing great. It's 2022 when new modules started, or new manufacturers started bringing new technology on board, and this is so how N-type is becoming more popular right now. So manufacturers are positioning themselves. Some of them are going through with one technology. Others are going with both technology, TOPCon and heterojunction, and some are still deciding, but they are investing heavily in both right now. Today, we might, or until a few months ago, if you want to minimize the LCOE, probably you will have to go to PPERG. Nowadays, we are right now, and this is reality, we are considering projects that we will be starting construction by the end of this year or early next year, and we are already considering TOPCon. So we believe that at this stage, TOPCon, so today is for some of the projects, not all, but for some projects is the best option. And what we get is a better efficiency, better bifaciality, and it's a bit more expensive than PPERG, but it's worthwhile. Heterojunction is like the next thing. It's coming. It's there. It's I mean, maybe in the next year there would be enough capacity, or maybe 2 years down the road would be enough capacity for mass products, for mass installations. Right now, what we have, we are analyzing, of course, and we have like temporary PAN files from the modules, which would be ready by the end of the year. So it's a big player, which will be here. We will be considering probably for the next project starting in the next year or two, maybe. Regarding the increases that we have found in generation with Topcom, we have seen between 2 to 3% increases compared to PPER, and with a heteroinjection, it's a bit more, maybe a 3.5. So the manufacturers, they claim even higher than 6%, but at this point we haven't seen it yet. But I mean, the truth is that there is a significant increase compared to PPER, so it's something to consider. With regards to structure, also, I mean, within Soltec, we have 2P and 1P. For me, the 2P is a more technical sound solution right now. It's because mainly because of the gap in between modules would have a positive impact in cooling effect and rear shade. If you see the pictures, so the one on the right, you see that's a thermal image. When the 1P, the lower side is hot. That's worse. It's not as good as for the system because thermal losses are the highest losses in a PV system. The fact that with a 2P, the fact that there is a gap in between modules will make easier for the air to flow and cool the system. That translates into an increased generation normally, and this is not for our projects for sure. But for some specific projects, the difference can be up to 2%. Again, not always, but it's worth it to compare. The problem with the 2P is that, of course, you need more material, you need more steel. Steel is very, very expensive right now. So at this stage, what we do is we analyze both. We consider both options and run both simulations and see which is the one that is giving us a better return or better LCOE. A very key thing that Mireia and Magnus are going to talk about algorithms. It's for us critical. It's protection, diffuse buster, and backtracking. This is very important. Unfortunately, PVSys is not, which is the mainstream simulation tool right now, is not able to consider those. But what we have seen is that you can use people like Tube to do a specific analysis for a specific project, and they will validate an increase, because there will be an increase for sure. How big? Well, it depends. I mean, and Mireia will explain further, but you might get easily up to 3%, maybe more. And if you can justify this with a third party report by Tube, for example, that's going to have a major impact when you discuss with banks. So it's worth it to do it. Regarding inverters, this is the traditional approach is beyond 40. You go with central. Below, you can go with string inverters. We have seen projects even larger than 100 that goes with string. This is again has to be analyzed project by project, and the reason behind this is that capex is a bit higher with the string, but lower, but OPEX is lower, and the generation a bit higher also with string. So we always recommend to do a case by case. Something important also is for the pitch nowadays, at least for us, it's all about bifacial modules. So we only work with bifacial, and because of that, it's very important to have this gap. The higher the pitch within a reason, the better. There is more space for the light to project and reflect into the backside of the panel. This is important, and just in that table that we see here below, we see how, and this is for a 2P, from going from 10 to 12 meter pitch, you can gain up to 2.5% in generation. Again, not for all projects, but this is a good indication of what you could get. Regarding the DCAC, again, this is something also that is changing. when compared to monofacial. Now bifacial, the nameplate of the modules is just the front side. So in reality, a bifacial module all with the same nameplate will have also always a bit more power than a monofacial. What we do here is we always compare. We always do several scenarios. We may run 115, 120, 125, even 130, and we select based on the project. And finally, for the PVC assumptions, I mean, I've summarized just a few of them here, but what we do is we work with every single assumption, every single, it's you might gain like 0.3 here, 0.2 here, 0.1 here, but adding it might have an impact. It might have an impact, an important impact in the project. So for the first one, it's the long-term database. PVC, of course, is coming with Meteonorm. We have seen that many times when you work with solar GIS, there's a cost associated, but it's a more accurate database, and you might get better results in many cases. So it's worth it. Regarding the thermal model, also this is very important too. This is for the tracker, and you need that the tracker that you are using has a third-party validation about this. Thermal losses are the highest losses in a solar PV system. So normally PV system, what is considered is 29.0 for this model, which is not real. I mean, that means that with a zero, what this PV6 is considering is there is no effect of cooling power of the wind, which is not true. So it's good to work with a thermal model that has been validated, so you can defend your numbers against the technical advisors or banks, because it will have a positive impact. Real shading is the same. If you're working, for example, with a 2P, that is going to be they will benefit from lower real shading. Albedo nowadays, it's mandatory. That's for sure. You need a campaign, because it's important to prove to the banks and technical advisors that there is grounds for a potential increase. So you have to prove that. And just as an example, IIM losses in IIM, we have seen in different simulations how it vary depending on the module, from even 1% to 0.15. That's a huge difference. So you always need to talk to the manufacturer and make sure that you have the latest span file and the latest validation from third parties, because otherwise the advisors will go to, I mean, we have seen it, we have lived this, that they might want you to get a 0.8 when, if you show all the information that you prove that third-party reports, you can get down to 0.3. So it's all about justifying and trying to increase your generation with justified, in a justified way, with normal, especially with you work with third-party reports. And this is all I wanted to say. If I'm open to any questions later on. Thank you very much.
Thanks. Now we'll turn it over to Maria Jimenez, and she'll walk us through Soltec's role in this.
Already, so let's start. Well, thanks to PV Magazine for giving us the opportunity to present our work here, because, well, there is a problem when it comes to maximizing production under adverse conditions. Adverse weather conditions are increasingly frequent and cost, well, millions of dollars in damage and to our photovoltaic plants. So understanding the risk from the combination of snow and wind, as well as the need for trackers integrated with intelligent monitoring and control to mitigate those risks, will be critical for owners and insurers. Soltec is a leading solar tracker manufacturer. At this moment, we have more than 16 gigawatts of trackers with contracted and ongoing projects. and we are developing our own projects, as Milo said, all over the world. We have more than 1,300 people working at Soltec and its subsidiaries, and we have offices all over the world. Soltec history goes back more than 15 years. We started in 2004 as installers, and in 2007 we developed the 10K5 tracker. It was a dual axis tracker that already incorporated wind and hail protection algorithms. In case of hail, the tracker moved the panels vertically to avoid damage. Since that first tracker, we have evolved our products a lot, going through the SA series, which was a multi-row, then the first solar fighter for residential use. And that one will help us to use the tracking technology that we use in that one to create the SF utility. That was the first 2P tracker on the market. Since then, we have been optimizing the product and diversifying our portfolio to offer our customers a wider variety and to be able to adapt to their needs. And the last one that we launched was the SF1. That one, it's a dual row 1P tracker that we're very proud of. But in any case, today we are talking about the algorithms and the production. And while the production of the solar tracker needs to be maximized, it's important to ensure that the tracker remains in a good condition during the working years. For this reason, a proper design is a key factor, but also the algorithms used during the operation of the PV plant. Okay, I want to be brief about the design, but I think that it's important to see also the evolution of the industry in terms of wind, because, the first step to prevent damage, it's a good design. Soltec has put a lot of effort in understanding how the wind affects the trackers and see all the possible optimizations without putting the structure at risk. Since before 2015, already in 2013, 2014, more or less, we started with rigid wind tunnels with a maximum cord that is the tracker width of 4 meters. Then we incorporated sectional wind tunnels to see the critical instability speed and the elastic effects of the wind. All of this led us to the die wind methodology developed with RWDI. They are experts in wind. They are consultants in Canada. They did the wind study for the Burj Khalifa. And we developed this methodology to consider dynamic wind loads and elastic instability limits based on the buffeting and fluttering of the tracker. What we see here as BAM and FAM, that it's the galloping of the tracker. In 2020, with the results of the die wind, we made an elastic wind tunnel that we can see in the video of the right. It's not, you can see it moving. And we can see the behavior of each tracker according to their position within the layout. It depends if it's an external tracker, if it is at the second row, or if it's an internal tracker. And with this, we use a database both in 2D and 3D with calibrated CFDs, so like the ones that we can see it here, simulations to calculate all kinds of scenarios. In the video of the left, we see an example where we analyze a hybrid stow situation. This database includes tracker widths from 2 to 5 meters, different tracker distances in east-west direction, different lengths, even the use of dampers, the slopes, whatever you can imagine, all the parameters that we face in a particular way in each project. In 2021, we updated the wind tunnels to adapt to the new, wider, larger modules formats, and we started with the validation of the SF1 version to incorporate its coefficients to our die wind methodology. For this process, we also joined, we include also CPP Wind, another of the largest wind expert consultants in the world, with extensive experience in 1P trackers, and today we have already incorporated it in our a calculation model. This process for us has been relatively fast because, well, it was a matter of months, thanks to all the knowledge and resources that we have put over the last years in these fields. Because as I said, well, a proper design is a key factor to ensure the reliability of the tracker, but also, again, the algorithms that you use during the operation of the PV plant. At Soltec, we use ultrasonic sensors to take into account not only the speed, but also the direction of the wind. This, together with the position of the tracker at the time of the alert, will lead us to decide the best defense strategy to protect the tracker without penalizing the production. It is also important to understand that the trigger speed can change depending on the wind directionality in order to not penalize the production. And in addition, well, different values are taken from the plant to track the gas speed to decide if it's necessary to go to defense position or not. At Soltec, we have been improving the wind algorithm for years, as many years as we have been working with RWDI, more or less, and we have a lot of experience in this matter. About the hail algorithms in Soltec, it is used since our first tracker, as I mentioned, the 10K5. But you can see here a picture in the right that to prevent the modules to break when a hail event is happening. There are another algorithms for snow, flood, thunderstorm, which brings us also to the algorithms related to the electronics and communication system. Within the electronics, we would have if any operator activates for example, the stop button, if there is a failure in the communications, if there's a low battery, or if, for example, there is another current or another voltage in the motor. Motor overcurrent algorithms aims to prevent the motor and battery from breaking and to try to get out of the stuck position. For example, in the case of a snow event, if there's so much snow and for any reason there's any problem, if the motor tries to move it, this protection will protect the whole tracker to damage the motor. The motor under voltage algorithm is intended to protect the battery, the electronics, and the motor, since if you have a prolonged movement of the tracker at a voltage below the recommended, that can cause breakdowns. And now the algorithms for maximizing the production. First of all, it's security, but again, you need to consider also the production and to make sure that you're also maximizing everything. Well, our team track, firstly, for sure, assures and secure the tracker plant operation, independent of external communications, and provides secure remote data communications. We adapted the algorithms for both independent and dual row. You can see here in the pictures, the one on the top, the one here, well, this one will be like regular tracking, and then inside of this square, well, the one here is for independent row, and then here for the dual row. The team track 3D uses umbrella sun position data versus program constants of local irregularities to execute energy optimized backtracking, position control, avoiding inter-row shading, and achieving yield gain. Tracker control is simply configured with irregularity parameters that don't change with the time or external influences in normal operation. Our team track stands out from existing solutions that add equipment and feedback response mechanisms that add cost and vulnerability. And this enables cost reduction in earth grading on contours and steps, since we can adapt the tracker and we can avoid the shading. And with this system, it has zero maintenance and provides for hardware independent software update. The result for the case of, for example, well, Magnus will talk more about this, but with the study that we did with Tube in the case of our regular terrain in Mediterranean latitudes, that are the ones that are presented here in this graph, we have considered here 3 strategies of backtracking. We analyze, well, to get the results that you can see here, that was standard tracking, standard backtracking, and the team track. The study of Tube verified that that Soltec team tracks could obtain 6.2% more energy than the standard tracking in regular terrains and average latitudes. The optimization compared to standard backtracking is 2.3 more or less, 2%. And furthermore, the study concludes that compared to the standard tracking, our algorithm obtains production gains ranging between 3.6 and 7.5%, depending on the terrain and climate conditions. If a comparison is made to a standard backtracking, annual optimization ranges between 1.2 and 3.5%. Algorithms gains again depends on terrain regularity, latitude, and the local conditions. Also, well, with Tube we verified the diffuse algorithm booster. The objective of this algorithm is increasing the production of the PV plant even on cloudy days, meaning when there is more diffuse than direct irradiance. The algorithm, which uses both sensors and weather forecast, moves the tracker to the optimal position that captures the maximum irradiance. In this way, the algorithm increases production of cloudy periods by 5.3, 6.8, something like that. I cannot remember exactly, but in that range, depending on the latitude again. And the diffuse booster is, well, one of the algorithms that make a Soltec team track extended package, which which aims to make the plants smarter, to optimize the production. That way, we can anticipate and orient the trackers to the most profitable way. And how does the diffuse booster work? Well, the best tracking system has to include the diffuse energy optimization functionalities. The graph that shows here the performance for this function compared to the standard astronomical tracking through a representative day in which the sky gets cloudy at the end of the day. Early in the day, the sun shines, and therefore trackers maintain their orientations. And as the clouds appear, irradiance on the oriented plane decreases considerably, fluctuating and as the sky gets overcast and horizontal plane irradiance exceeds steadily oriented irradiance. The lower graph shows how, well, through this period, the angle of the tracker in astronomical tracking remains oriented to the sun positions, as shown in the center picture below, whereas the tracker with the diffuse booster active remains horizontal to optimize energy and capture all the radiance, as shown in the last picture. So the energy collected by the tracker in optimization mode, it exceeds here it's 94 watt-hours in the astronomical mode. So we have here a daily generation improvement of 1.4% for this day. Here we see a comparison for an example of a fully cloudy day. Tracking with active diffuse booster increases capture irradiance here, improving the full day power generation by 12.4%. So you can see offering instantaneous improvement peaks of 29%. This is in this, like if we compare in this day, if we kept the tracking system instead of putting in the diffuse mode, then the increase, you have peaks up to 29, 25% in some moments. So the implementation of the team track, including basic team track for backtracking and diffuse booster algorithms, may raise the year energy yield up to 6.3% in Mediterranean regions. Again, it depends on the location and depends on the latitude. So if we consider that for a specific case, we can have bifacial gain for using bifacial modules, we add the basic backtracking strategies to avoid shadows on the front face during the sunrise and sunset, and then with what we Soltec propose is to use a package of algorithms that optimize the electricity produced depending on the diffuse radiation, bifacial parameters, or even the module temperature. Okay, in this case, the total bifacial gain it's around 15%. And to be able to monitor both security parameters and algorithms, it's necessary to have a good tracking monitoring system, what we call the TMS. Our TMS is part of our full wireless system with distributed control, which makes the system more reliable. It's able to detect anomalies, and it has an alarm management that it's key for the operation for the operation team. So just to sum up, while PV plants are often exposed to hazards that put the installation at risk, becoming an unpredictable economic investment, tracker design must consider the aeroelastic effects caused by the wind. This is the first step always to prevent any damage. So Soltec trackers have always die wind implemented. The electronics integration is also required to face weather phenomena, and priority management in algorithms is key and can make all the difference when it comes to optimize PV plants' performance and protect the integrity in case of unfavorable weather. Team backtracking is always enabled, and an optional additional algorithms package to consider diffuse radiation, bifacial parameters, and module temperature. It's also something that we recommend here in Soltec. So thank you very much. I don't know if you have any questions, but we can keep going later.
Thanks. We have a few questions, but we'll field them at the end. For now, we'll turn it over to Magnus Hers of TÜV Rheinland, talking about the verification of asymmetric backtracking algorithms. Thanks, Magnus.
Thank you, Ryan, for the introduction, and also from my side, warm welcome to this webinar. First of all, I'm still recovering from a cold, so please forgive me my bad voice, and maybe I have to make a quick break between the slides. So nevertheless, as Ryan said, I'm an expert a solar expert from TÜV Rheinland. TÜV Rheinland is one of the world-leading tech companies. We are celebrating our 150 years this year, and we are also in solar in business in several years. Here we have also anniversary from 40 years. In total, TÜV Rheinland has around 20,000 employees around the world, and more than 250 of these are solar experts located in our 6 PV laboratories, also located around the world. And in total, we have inspected more than 20 gigawatt of PV projects. And we are our solar services we are offering for the full value chain, beginning with the development of products and also projects, and we are also supporting during construction phase, and we are here for the commissioning and also give consultancy during operation time. As said before, TÜV Rheinland is a classical TIC company. What is meant with TIC? It's testing, inspection, to certification. It means we We offer to characterize the behavior of products. Then we also inspect components and compare it with the specifications. And last but not least, we are also a third party who can attest these characteristics of the product. And not only hardware and products, we are also offering the testing and certification of processes and also of software. And here we step in for the Soltec team track algorithm. Here our objective was to do such a third-party verification of this tracking algorithm. And before we started the project, it was important to define the requirements for this algorithm. And we said we do a verification in this case. It's something between testing and certification, but it meant that we check that the software system meets the specifications, the requirements, so that it fulfills its purpose. And in this case, we had four goals. The first was that the position control have to avoid inter-row shadings in the early and late day hours. And the second one, that it should be tested that each tracker is positioned at a different angle during the full course. And then we wanted to verify if there's an increase in projection due to this algorithm. And in addition, it was a extended behavior. We checked the slow diffuse algorithm in addition to the normal team track algorithm to see if there is even a higher gain from this algorithm, and if he also fulfills the purpose. How have we done that? The idea was to do a black box verification that that meant that we had to remodel a full system, and with the remodeled system, we defined all the positions of the trackers, and then simulated the output over the full year. In order to have a more robust evaluation, we defined several scenarios. So in order to avoid having it biased by a certain location, and therefore we defined different locations, and we defined also different types of terrain. So what to identify the impact of the different terrain on the output. And at the end, we calculated the increase or the differences in production between the standard tracking and the team track backtracking. So we defined here the reference, and the reference was standard tracking. Here you can see our three defined locations. We had one in the Mediterranean region, and one in the northern latitude, and then one next to the equator. And that has something to do with the fact that the algorithm is strongly depending on the latitude. That means depending on your location, depending on the latitude. So the longitude is not the driving factor; it's more the latitude. You will see that the benefit of the algorithm will change. It's not only the latitude, we have also different climates. We can see that we have one semi-arid dry climate and one humid maritime climate, and then the tropical wet and dry climate. And we have also different diffuse global irradiation ratios. So that has something to do with the gain of the slow diffuse algorithm. And as a meteor data, we selected a typical meteorological year calculated from 20 years. Beside the location, we have also three kinds of terrains, and we named it very irregular, and regular. You can see on the top right corner the surface model for such a very irregular terrain. And in the table, you can see the statistics for how the terrain is defined besides the name. So you can see that the very irregular, we have a strong east-west deviation of the altitudes and north-south deviation. For irregular, it's more, we have a strong deviation in east-west deviation, and the regular terrain is not completely flat, but it's next to a flat surface. The selected system is called a reference system, was for all of the scenarios the same. It was a medium-sized PV system with 8 megawatt installed capacity. Then we have the one-axis 2P tracker. We have ground installation with a certain component and a certain inverter. And for the full field, we had 256 of trackers installed and 3 strings per tracker. What you can see here is already the results from the shading calculation. We can see on the bottom three pictures for one situation at at 8 o'clock in the morning in June. And what you can see is that the standard tracking and the standard backtracking, we have several areas shaded. So, a shaded area you can identify here on the picture as a black area. So as long as your tracker is right, it means there's no shading on the next tracker. And as soon as you have here black areas, that means that you have a shadow cast by your tracker before. And we can see for the team track, all of the areas are still white, though we have a fully unshaded situation here. What we can also see on the right top corner, we can see the amount of shaded area. And we have here again the 3 settings. And it's clear for standard tracking, without backtracking, you can see here the slope as more module area shaded. And then for backtracking, you can see there's again somewhat less. And then for the team tracking algorithm, we have the least amount of area shaded. The shaded area is not linear to the yield, but still it's a good indicator to see if the algorithm fulfill its purpose. And when we now look at the yield, we have already seen similar graphs from Mirera, though I will not go in detail here, but we can see on the left-hand side the comparison of the 3 algorithms on a monthly basis. We can see we have for each month the green bar, the team track algorithm has the highest output. And when we look on the absolute values, then we have in the summer months some higher benefit than in the winter months. But it's just a qualitative result here from one of all the scenarios. So I do not mention here any number. But to see here the behavior over the year, on the right bottom corner, you can see the daily curves of all the three algorithms. And we can clearly see that in the morning and in the evening, with backtracking, you have already more power than with standard tracking. And then when we look at the green graph, then we see that with team track you have even more, and that could be up to 10% for a single day, but not over the whole year. We will see in the next slide the results for the full year. What before we go to that, just one last comment. On the top right corner, is the comparison between team track and team track plus the stow diffuse booster. That means we have for a cloudy day the diffuse booster into as active, and you can see that the increased gain by such a diffuse booster could be in for single days also up to around 10%. Then let's go to the final slide. As I said, one of the targets was to verify that the algorithm meets the specifications, and that we have achieved. Then during the verification of with the 27 different scenarios, we can also confirm that the algorithm leads to higher annual yield gains in the range between 3.6 and to 7.5% in comparison to a standard tracking algorithm, and between around 1% and 3.5 in comparison to a backtracking algorithm. In the metrics below, you can see that it depends on the terrain and also on the region, and then you can see here the numbers for the different scenarios. And when we add also the diffuse booster algorithm, the output is even higher, and here it's 4 to 8.3% for regular terrain. So that's from my side. I thank you for the attention, and I'm also open for questions.
Well, I want to thank all of the presenters. We'll open it up now to a question and answer session for all of our presenters. We're pretty close to time here. We may go about 5 minutes over. Any questions that are unanswered, we can go ahead and forward to our presenters today. And sometimes we'll do a follow-up article to address any questions unanswered. But to start, we had a few questions about climate change and its role in the development of these algorithms. So I was wondering if you could speak to, in light of how the climate is changing, how accurate are historical weather databases? And these databases, are they available in any city? And how do you see sort of the accuracy of them going forward affecting how these are developed?
Well, during the operation, the good thing about our algorithms is that we use, for example, for the diffuse booster, the forecast. So what we analyze, for example, for the cloudy days or for the module temperature, it's the data that we have in that date. But it's true that when you design a tracker, the parameters, for example, for the wind loads that you use, just usually are historical data. What we need is to comply with the local codes, but there's also a safety factor that we include in order to absorb those scenarios. When you design a tracker from the structural point of view, you have that factor that this never happened in 50 years, 100 years, 700 years, things like that. And those are the parameters that the customer needs to ask every tracker manufacturer how they calculate it, because that's a safety factor for sure. It needs to include that possibility that since the climate change it's a fact, the historical data for 50 years maybe not be the best approach.
Thanks. And to follow up on that, we had a few people asking, what are like the top steady wind speeds and gust speeds that your trackers have survived historically? Is there data available for that?
Well, we have a project in Hawaii that the design loads are 120 miles per hour. About the gust, I'm not sure about the most one, but well, the tracker that we have in Hawaii for a 2P tracker with a stance at 120 miles per hour.
And then we have a question for Magnus here. The question was that what IEC standards apply to tracking algorithms, and what is the standard test for a tracking system performance?
A good question. For the algorithm, I'm not aware of a IEC standard. So that was also something to develop a procedure which is suitable and is following different standards, but there is not official where you can say here you have here the recipe and then you can apply it. When we speak about the algorithms, there are standards for the certification of the product itself, and also for safety issues and so on. But I think here Mirera can give her a larger answer to that. And because I'm not the expert for their hardware testing in this case. So, but I know from my colleagues that we have also the components in the laboratory, but not testing the performance or any algorithm.
Thank you. And this one's for Emilio. You mentioned that there's a trend of more and more string inverters being implemented in larger projects. I was wondering if you could talk to the factors that lead to that increased adoption in large projects, and if you see that trend continuing in the future.
Yeah, I think, well, again, as I mentioned, there are projects where that's a good option. And the reason behind that is that there is traditionally the string inverter has been more expensive than central inverters, but this gap is getting reduced lately. And that's one thing. The other thing is from the operational side, O&M is cheaper to maintain a string inverter plant, and it's like it's a more of a puzzle. There is a problem with the string inverter. You just take it, put a new one, and nothing is blocked. I mean, it's the generation continues. It's affecting just one tiny part of the plant. And also because of that, generation tends to be a bit higher. However, of course, the central inverters manufacturers are understanding what is the situation now, and what they do is they build bigger central inverters, but in a modular place. So I mean, let's say they might be like a 6 megawatt central inverter, but they would work with modules of 1 megawatt each. So if there is one specific issue, it's not going to affect the 6 megawatt, but only the one section of 1 megawatt. So that's we always mention, analyze. We that's what we work with all manufacturers, all technologies, and for specific projects, we work and we see which is the best option. But this is specific to manufacturer, but sorry, to inverter, but it's, I mean, same with the trackers, same with modules. It's all about location and what is how the technology is available at the time.
Thank you. And then for Mireia, we had a question. What's your recommendation for stimulating the gains that are achieved through these advanced tracking strategies? And are there any other softwares other than PV-Syst that can be used with that? And if maybe you could talk about the bankability of other solutions used.
Well, PV-Syst that simplifies a lot the way that calculates. It's fast for sure, but it needs to be parameterized. That's why we also work with Tubreglan to be able to analyze that production. We can have some internal software to make those estimations, but if you want like a very accurate numbers in order to be able to be used for bankability purposes, then you need to check it with third parties, so as to here.
And just Ryan, just let me comment something here. As a developer, I think that's very relevant. I was telling before, if you are able to justify like a 2%, 3% increase in generation, so would I would be very happy paying the fee to do that analysis with Tube, for example, or it will make a massive impact in the valuation of your project. So it's for us it's a no-brainer. Yeah.
Great. And we had another question about research and development and sort of the future of trackers. What are the current challenges and hurdles that are working to be overcome right now?
Well, we're working on extend our algorithms package to absorb more possible scenarios, to be able to adapt well to any terrain, to any model type. That's one branch to continue, and also to continue with different uses of trackers, for example, for ecovoltaics like agrivoltaics, and to adapt the algorithms for those scenarios when you use agriculture with tracker as well.
And another question about backtracking. How can you optimize backtracking from the start? Basically, at what angle should backtracking begin?
Well, I think that Magnus knows more about this. But again, it will depend on the position of each tracker, on the coordinates inside of the layout, and taking into account the trackers that they have north, south, east, and west, and to analyze that.
Thanks. And then we can field one more question, and then we'll be able to follow up with these questions. We'll send them to our presenters so that we can get the response. Had quite a few today. One question on what kind of wireless technologies are being used to sample the data in the field, and what kind of sampling rate is used to collect that data?
Well, the protocol we use, it's OpenThread for the full wireless system. There's also in the market a Zigbee or LoRa systems, and the radius changes depending on the technology used. I don't want to lie here, so I'm not sure about the hours. I will need to check that, but we can check it. We can send the answer later via email or something.
Great. Well, I want to thank all of our presenters today for sharing all this great information. Like we said, there's quite a few questions from the audience, so we'll go ahead and package those and send them so we can get some answers to you. And keep your eyes open for an article in the future that'll be addressing all of those. And again, if you enjoyed our presentation today, be sure to check out our website. I'm editor for PV Magazine USA. We had a couple recent articles that were popular about the halting of solar tariffs from the US and what that impact may be. We also have a print magazine. If you scan the QR code there, you can get 10% off your subscription with the password webinars10. Thanks again. This has been PV Magazine webinars. We have a few coming up, including one tomorrow, Chasing the Sun, Advanced Analysis for Innovative PV Materials, and then another one on the 30th, Alleviating Battery Storage Pains Through Quality Assurance. And many more to come. You can scan the QR code there for the full list of events, and you can find that on the website as well.
Thank you, Brian.
Thanks very much.
Thank you.
Thank you. Thanks a lot.